In a world where speed dominates the skies and stealth defines supremacy, there still remains one unstoppable force that conquers not by finesse, but by sheer size, an airborne giant so massive, so incomprehensibly vast, that it dwarfs fighter jets, eclipses bombers, and defies every preconceived limit of human aviation. Welcome to the story of the largest aircraft ever built in the world. A titanic machine engineered to lift what no other plane dares to carry, crafted not for combat but for capability, and designed to leave the very earth trembling beneath its shadow. Whether you're a die-hard aviation enthusiast or just someone with pulse, witnessing this airborne behemoth in motion is like watching a skyscraper come to life and fly. We're talking about a plane so large that its wingspan surpasses an entire football field, so heavy that even concrete groans beneath its wheels, and so majestic in flight that it has become a legend not just of engineering, but of national pride. There are aircraft that broke sound barriers, aircraft that redefined dogfights, and aircraft that rewrote stealth. Yet none have done what this beast has done, simply by existing. Among these leviathans, two names dominate history: Antonov An-225 Mriya and Stratolaunch Rock, both built with wildly different missions, but both holding the title of largest in their own terrifying right. The Antonov An-225, the original king of the skies, was born from Cold War urgency, designed in Soviet Ukraine in the 1980s to haul the Buran space shuttle and payloads no one had the audacity to ask for. It featured 6 massive engines, 32 landing wheels, and a wingspan of 290 feet. But its reign was one of sorrow and sacrifice. Built only once, its twin was never finished. The An-225 was a heavyweight champion of logistics, lifting over 250 tons in a single flight, transporting massive turbine blades, tanks, and even emergency pandemic supplies. The world stopped to watch when it flew. Airport runways were cleared. Cities paused. It was a sky titan, the cargo colossus. And then, in one devastating moment, it was gone, destroyed in 2022 during the war in Ukraine, a brutal symbol of what war takes from humanity's brightest dreams. But the story didn't end there. Rising from the ashes of history and into the modern era came another behemoth, not Soviet-built, but American-engineered. Stratolaunch Rock, the largest aircraft by wingspan ever flown. Created by the late Microsoft co-founder Paul Allen, Stratolaunch was designed not to carry tanks or shuttles, but to launch rockets into space, serving as a mobile launch pad for orbital payloads. With a wingspan of 385 feet, yes, wider than any aircraft or even the Saturn V rocket, it features twin fuselages, 6 jet engines, and a kind of surreal visual presence that makes people think it's photoshopped until they see it roar down the runway. It was tested in the Mojave Desert and now sits as a modern marvel in aerospace capability, the flying equivalent of an aircraft carrier, poised to redefine hypersonic weapon testing and commercial space launches. And yet, the world keeps pushing further. While the An-225 once symbolized brute Soviet muscle and Stratolaunch embodies American innovation and privatized aerospace strategy, new giants are on the drawing boards. Massive hybrid airships, nuclear-powered cargo carriers, drone motherships, and orbital launch gliders the size of city blocks. China, too, is racing to enter this niche of sky domination with rumors of its own ultra-heavy lift aircraft, potentially rivaling even the Mriya in scale, but blending stealth and AI for autonomous intercontinental logistics missions. Meanwhile, DARPA and NASA are teaming up with private firms to design ultra-efficient megalifters powered by hydrogen turbines, capable of operating from Arctic bases to desert launch zones, all aimed at enabling rapid, global reach of heavy systems without needing fixed infrastructure. These aircraft won't just carry cargo, they'll carry futures. When you imagine humanitarian aid being dropped into disaster zones from a single aircraft, or mobile hospitals being flown into remote war-torn regions, or entire missile defense systems being repositioned overnight, this is what the giants of the sky are made for. They're not just tools, they're airborne strategy. They project power, capability, deterrence, and reach. But let's take a step back and marvel at the logistics behind such titans. The Antonov An-225, for example, required over 6 crew members just to operate, consumed more fuel per hour than some entire regional airlines, and had to land on reinforced runways. Yet it was often the only aircraft on Earth that could deliver its payload. It flew from military bases to global ports and from manufacturing hubs to disaster zones. Its presence was so valuable that NATO allies routinely requested it for urgent operations, and countries would often bid for its service. Its replacement, rumored to be in early planning stages by Ukrainian aviation specialists, maybe even larger, designed with modern composites, electric-assisted turbojets, and digital avionics, but no official confirmation has emerged. As for the Stratolaunch rock, its mission has evolved from satellite launch to becoming the ultimate platform for hypersonic weapons testing. Imagine a plane that can take off, climb to high altitude, and launch a Mach 5 plus missile right from the sky, reducing the need for expensive ground-based infrastructure or fixed launch sites. It's the future of flexibility in air superiority. With hypersonic missiles now reshaping military doctrine, the ability to test them safely and reliably from a flying platform is invaluable. And yet, despite all their might, these aircraft are fragile too, expensive to maintain, complex to control, and massive enough to attract diplomatic, environmental, and strategic attention wherever they fly. Their size makes them targets, both politically and militarily. It raises questions. Should we invest in size or stealth, in mass or maneuverability? The U.S. Air Force still believes in both, designing next-gen air tankers and cargo jets to support the new air combat ecosystem, where drones, fighter jets, satellites, and yes, flying fortresses must work in unison. Even in civilian aviation, giants like the Airbus A380, once hailed as the future of mass air travel, have proven that size alone is not always a commercial winner. But in military logistics and aerospace launch, the game is different. It's about capability, not ticket sales. And as we stare into the next decade of aviation, one thing is undeniable. The skies will be filled not just with speed demons and stealth bombers, but with giants. Flying machines that challenge gravity not just technically, but ideologically. They say the age of giants is over, but we say it's just beginning. Because when the world needs to move the unmovable, lift the impossible, or deliver hope where roads and ports cannot reach, there will always be one aircraft that answers that call. The largest aircraft ever built in the world is not just a record breaker. It's a symbol, a signal, a message that human ingenuity has no ceiling. And with every thunderous takeoff, it reminds us that the sky is not the limit. It's only the beginning. But to truly understand the scale and significance of the largest aircraft ever built in the world, we must journey deeper, not just into the specifications, but into the heart of what these aircraft represent in geopolitical power, human ambition, and technological daring. When nations design such giants, they're not merely creating flying machines. They're projecting strength, unity, and a refusal to accept logistical limitations. These airborne behemoths are strategic chess pieces that alter the rules of the global game. Think about it. A single aircraft capable of moving space-bound rockets, combat-ready hypersonic systems, or life-saving equipment to anywhere on the planet within hours. That is not just engineering. That is air dominance. And few stories capture this better than the legend of the Antonov An-225 Mriya, which, translated from Ukrainian, means dream. A name fitting for an aircraft born from the vision of transporting the Soviet space shuttle, Buran. When it first flew in 1988, engineers and aviators alike stared at it in disbelief. At 276 feet long, with a wingspan of 290 feet, and weighing over 700 tons when fully loaded, the An-225 shattered expectations and records. Its 6 Shevchenko Progress D 18T turbofan engines delivered over 51,000 pounds of thrust each, lifting payloads of more than 250 tons into the sky. Inside its cavernous belly, the An-225 could hold battle tanks, power plant components, wind turbine blades, and even other aircraft fuselages. For decades, no other plane even came close. But despite its raw power, the An-225's existence was precarious. The fall of the Soviet Union left it grounded for years. It was only resurrected in the 2000s for commercial cargo operations, where it became a global phenomenon, drawing crowds wherever it landed. It became a lifeline during the COVID-19 pandemic, delivering supplies to countries in crisis, and earned a near-mythical status in aviation history. Then came tragedy. In February 2022, during Russia's invasion of Ukraine, the An-225 was tragically destroyed while grounded at Hostomel Airport. The aviation world mourned. Engineers, pilots, fans, and entire nations expressed grief not just for a machine, but for a symbol of human possibility. But even in death, the Mriya story wasn't over. Ukraine has vowed to rebuild the aircraft using salvage parts and updated technology. The second, incomplete Mriya, long hidden in a hangar, may yet rise, and when it does, it won't just be rebuilt. It will be reborn, with modern composites, AI-based flight controls, and next-gen propulsion to make it the 21st century giant the world needs. But as one giant fell, another rose. Enter Stratolaunch Rock, the current king of the skies by wingspan. Built in the United States by Stratolaunch Systems, this dual-fuselage monster aircraft boasts a wingspan of 385 feet, longer than an American football field, including end zones. Developed to launch rockets into orbit from high altitudes, Stratolaunch isn't just an aircraft, it's a flying spaceport. Its design is radical. Twin cockpits, 6 Boeing 747 engines, and landing gear with 28 wheels. Flying at altitudes over 35,000 feet, it can drop-launch rockets that ignite in midair, avoiding costly ground-based launches and allowing for faster, cheaper access to space. Its mission has since evolved into one of national defense, where it's being repurposed to test hypersonic systems that could define the next generation of warfare. Imagine a Mach 7 vehicle launched from a flying platform, dodging satellite detection, and crossing continents in minutes. That's not sci-fi. That's a Stratolaunch roadmap. As of now, Stratolaunch has completed multiple successful test flights, proving its capability and earning its place in the history books. But Stratolaunch is only one direction of growth. Around the world, innovation is scaling upward. In China, new aerospace giants are being designed to rival American and Soviet achievements. State-backed companies like Aviation and CLT are rumored to be working on super-heavy cargo platforms capable of launching drones, missiles, or even small spacecraft directly from the stratosphere. Their goal? To ensure China dominates not just the sea or the internet, but the very skies themselves. And then there's a mysterious world of black-budget projects, covert aircraft that may already surpass known giants in function, if not in size. The U.S. has long funded secretive aerospace programs through DARPA and the Air Force's Rapid Capabilities Office. What if there are already aircraft larger than the An-225 or Stratolaunch operating in classified roles? Surveillance motherships, drone carriers, or electromagnetic payload platforms. We may not know until decades later, just as we didn't know about the U-2 or State Route 71 until long after they first flew. Meanwhile, private enterprise continues to dream big. Companies like Aeroscraft are developing massive cargo airships, blending old Zeppelin-style airframes with modern propulsion and cargo systems. These Sky Titans promise to carry hundreds of tons across continents without the need for runways, landing vertically on any surface. Hydrogen-powered, AI-guided, and immune to traditional radar, these mega airships might become preferred logistics tool for hard-to-reach conflict zones, remote mining operations, or disaster relief. Even NASA and Boeing are exploring new ultra-heavy lift platforms that can serve both atmospheric and orbital roles. The idea? One aircraft that can serve as a fuel tanker, cargo hauler, drone launcher, or space plane carrier, essentially a Swiss Army knife of the skies. With modular bays, 3D printed parts, and adaptive flight systems, these platforms would change everything from warfare to humanitarian aid. The U.S. military is also investing in large-scale aerial drone carriers, turning aircraft like the C-130 or even future variants of the C-17 into autonomous drone motherships. These would carry, launch, and recover swarms of drones midair, capable of attacking, spying, jamming, or relaying data in real time. This isn't theory, it's in testing right now. The Pentagon's vision for 2030 and beyond includes air dominance not just through superior fighter jets, but through sky networks, massive aircraft coordinating fleets of smaller ones in a dynamic, ever-shifting aerial battlefield. It's not the biggest that always wins, it's the biggest and smartest. And then there's the cultural and symbolic power of these giants. When a Stratolaunch flies, or when the An-225 once flew, it wasn't just an engineering marvel, It was a statement. It told the world, we can build the impossible. It told adversaries, our reach knows no limits. It told allies, we'll deliver what you need, wherever you are, in humanitarian missions. These aircraft brought aid to the unreachable. In times of war, they moved vital systems quickly. In the commercial world, they delivered massive wind turbines or entire sections of infrastructure. And on YouTube, they captured the imagination of millions, some watching from runways, some from couches, all united in awe. No CGI could match the thunderous roar of 6 engines lifting a Leviathan into the sky. And no drone footage could ever truly capture the gut punch of watching a 700-ton machine bend gravity to its will. And the future? It's bigger than ever. With AI pilots, nuclear power sources, shape-shifting airframes, and vertical takeoff capabilities, the giant of tomorrow won't just carry our cargo. They'll carry our dreams. And when these next-gen Titans lift off from U.S. airfields, backed by military innovation and private sector genius, they will once again show the world that America still leads the sky. The race is on. Russia lost its biggest. China is building its first. But the U.S. is preparing to build the last word in airborne dominance. Because in the skies of tomorrow, size still matters, especially when it comes with speed, intelligence, and firepower. The largest aircraft ever built in the world is more than a machine. It's a flying monument to what happens when courage, creativity, and ambition take flight. And in the age of uncertainty, when land borders close and sea lanes choke, the giants of sky will be the ones to keep the world connected, protected, and inspired. So the next time you see one rise into clouds, remember, it's not just lifting steel. It's lifting the legacy of all who dare to fly beyond limits. And the sky will never be the same again. And as we reach the final chapter of this awe-inspiring journey to the world of giant in the sky, the legacy of the largest aircraft ever built transcends the physical. It becomes spiritual, cultural, and political. From Cold War ideologies to 21st century innovation races, these aircraft embody everything a nation believes about itself and its place in the world. When a government greenlights a program to create a flying Leviathan, it's not just allocating funds, it's declaring to the world, we believe in our ability to do the impossible. The skies have always been the proving ground of empires, from the British airships to German bombers, from American space planes to Soviet cargo giants. Every great power has used the air to project its reach, influence, and dominance. And no aircraft does that better than the world's largest. But size isn't just about spectacle, it's about utility. These aircraft serve purposes no others can. When a natural disaster levels an island and roads and ports are destroyed, it's not a boat or a truck that brings the first wave of relief. It's a Sky Titan, landing on short runways or even a packed field, carrying food, water, medicine, and hope. When military bases halfway around the world need equipment overnight, or a space-bound payload must be delivered without margin for error, only the largest aircraft can answer the call. In fact, the logistics of modern warfare would be impossible without these machines. Consider the U.S. Air Force's C-5M Super Galaxy, a strategic airlifter that can transport tanks, helicopters, and thousands of troops across continents. Though not the largest by wingspan, its cargo volume makes it one of the most critical aircraft in American air mobility. It operates not in peace, but in pressure, landing in hostile zones, carrying urgent reinforcements, or evacuating the wounded. And every time its massive nose lifts to swallow more cargo, it reminds us, big aircraft win big battles. In the commercial world, the Boeing 747-8F still reigns as a cargo king, bridging commerce between Asia, Europe, and the Americas. Amazon, FedEx, DHL, they rely on these giants to keep global trade flowing. With e-commerce booming and next-day delivery becoming the norm, demand for ultra-large freighters is skyrocketing. That's why companies like Boeing and Airbus are exploring next-gen freighters with composite bodies, electric engines, and self-flying capabilities. Airbus Beluga XL, shaped like a whale and painted a smile, is more than quirky. It's revolutionary. Designed to carry oversized aerospace components, the Beluga XL transforms Airbus internal logistics, allowing wings, fuselages, and satellites to fly from one facility to another faster than ever. With a payload capacity of 51 tons and a massive cross-section, It's Europe's gentle giant, but even that is dwarfed by the conceptual designs emerging today. Lockheed Martin has proposed airships that could hover over war zones or disaster areas for weeks, acting as floating command centers. NASA's X-plane concepts feature blended wing bodies with gigantic lift surfaces and whisper-quiet propulsion systems, aiming for sustainability and power combined. And the most jaw-dropping of all, orbital transporters, planes so large they can launch rockets or space planes directly into low Earth orbit. The concept of a space plane carrier is no longer science fiction. Engineers envision aircraft longer than football fields, using magnetically assisted takeoffs, superconducting propulsion, and adaptive wing structures. These machines would serve both military and civilian needs, sending up satellites on demand or deploying hypersonic gliders with pinpoint accuracy. These are not just aircraft, they are airborne infrastructure. In fact, the U.S. Air Force is already studying the future of aerial bases, flying platforms that serve as command centers, drone launchers, and surveillance hubs. With AI co-pilots, solar-assisted flight, and unlimited flight endurance, they would never land, never sleep, and never stop watching. Imagine a world where the sky itself is populated with mobile fortresses, shifting, adapting, and responding in real time. That's the future the largest aircraft are unlocking. And for every ton of steel in these titans, there's a ton of national pride. When the An-225 flew, Ukrainians cheered. When Stratolaunch soared, Americans stood taller. And when these giants landed in foreign countries, people didn't just see airplanes, they saw hope, help, and human progress. Because in a world plagued by division, there is something unifying about watching the impossible rise above the clouds. Kids press their faces to airport fences. Pilots tip their wings. Mechanics pause and salute. These aren't just machines, they are legends. In the U.S., veterans who served on or around aircraft like the C-5 Galaxy or C-17 Globemaster remember the sheer presence of these behemoths. The roar of the engines, the shadow they cast, the vibration in the ground. It wasn't just technical, it was emotional. The first time you stand next to a 747 or Stratolaunch, you don't just see it, you feel it in your chest, and you never forget it. These machines become symbols like battleships or monuments, telling stories of sacrifice, ambition, and achievement. And as we look ahead, the skies are calling for even larger innovations. Climate change, space colonization, global disaster relief, all demand scale. Planes that can carry entire mobile hospitals, reactors, desalination units, or modular city components. The future may very well depend on our ability to fly bigger, faster, and farther. The next decade will be a race between superpowers to create the next great sky leviathan. Will it be nuclear-powered? Will it operate in orbit? Will it host drones, satellites, or even teleportation systems? We don't know, but we do know this. Whoever builds the next sky giant will lead the world into the future. So when we talk about the largest aircraft ever built in the world, we're talking about more than numbers. We're talking about human identity, about the relentless push to rise higher, about taking on gravity, doubt, and fear, and winning. And every time one of these giants touches the sky, it whispers to the world, we are still reaching, we are still building, we are still dreaming. The era of sky titans is not over. It's just beginning. And the next generation won't just fly. They'll reshape the world from above.